All right, so I did a little bit of shopping and I am ready to set up an APRS setup here. First, I should explain what's going on. I've had for a while now a Raspberry Pi with an SDR, just the bare minimum RTL SDR, basically just an iGate. It listens to APRS, uses Direwolf, very minimal, just listens, sends it to the internet. That's it. And I want to upgrade. I've been wanting to upgrade for a while to something that does digipeating, so I can get signals in and I can broadcast APRS signals out. So this is the DigiRig. This thing is basically a USB sound modem. You have your 3.5mm jacks here for the serial data and audio data with a little USB-C interface. It's a sound card. And the thing is, I don't really need this. I'm sure I could just use the Raspberry Pi itself, but it's sometimes easier to get the product that was designed for the application you're using than try to jerry-rig something. And these are pretty cheap, or cheap-ish, I would say. So yeah, here's the Amazon product page. It's DigiRig Mobile, integrated digital modes interface for amateur radio. So that's going to pipe audio to the radio. So in addition to the DigiRig, I have this cable, which will go into the DigiRig and into the radio. And it is shielded. It does have ferrites on it and everything, so it's going to be a good cable. So here's the product page for it. Just the DigiRig cable for the AnyTone AT-778UV. Okay, so here is the AnyTone 778, if I can't find it. Yeah, the AnyTone AT-778UV dual band 25 watt mobile radio. So you can use an HT. This is $130. It's not super expensive. But for where I'm going to put it, it's just the perfect shape, perfect size. It's going to work great. So we can just actually open it up. And what do we get inside? We get a manual, which is fantastic. We also get cardboard, lots of cardboard. And of course, we get the radio. There's also some other stuff in there, but yeah, so this is the radio. It's not very big. It's barely larger than an HT, barely larger. And an HT is basically one of those walkie-talkie ham radios if you're not into ham radio. And it looks like, oh, that's gonna be weird. So it has this weird connector. I've never seen this power connector before. We are going to have to change that so that you can get that into power pull mode. Let's see, it came with USB, I guess it's a programmer cable, USB to RJ45 or something. And yes, I do see power cables. And this will go to, anything. So I guess I will be adding power pull adapters to this tonight. I was not expecting that. Okay, well, I will do that tonight. But yeah, here's the radio. Very basic. I like it. Very small. Does 25 watts. I'm happy. This will be perfect for APRS. So this is the product page for the AnyTone AT-778UV dual band 25 watt mobile radio transceiver. So it will receive and transmit at 25 watts. So perfect for VHF APRS transmissions. Yeah, when I went to the DigiRig website, they recommended, weirdly enough, a audio noise eliminator, to get rid of ground loops, like a ground loop eliminator as well, but basically a ground loop eliminator. I ended up getting two things, and I feel like these aren't really necessary, but I would rather be too cautious than not cautious enough. So I ended up getting this, which is a power isolator, which will get rid of any ground loops. And this thing called the iSilencer, which supposedly, through some magic, I don't know if this is going to work or not, but supposedly it gets rid of some RF interference. Maybe I could do another video where I reverse engineer this and see if it actually does anything. But when you're working with radio equipment, it's so important that you have really good shielding, really good RF protection. We're going to be putting off some pretty strong signals. And, you kind of want to make sure that you're not picking any of that up into the audio interface, even though the audio interface is a DAC. So, it's going to be generating from, the Raspberry Pi, sending digital data over USB, and then you converting it into an analog signal. But if the ground trace is picking up like RF, it could potentially affect the output, maybe. The cable I got to the DigiRig is also shielded. So yeah, this is the power isolator, USB data and power isolator. So that's going to get rid of ground loops, supposedly. This is a shielded short cable by DigiRig, nonetheless. So this will be plenty shielded. Anytime I do anything with computers and radios, I shield all the cables like crazy. And then here we have the Wi-Fi silencer, which, like I said, seems to have mentioned something about RFI reduction. I don't know if it's I don't know if I'm being scammed or not. But we'll see. Like I said, maybe someday I will do a teardown of one of these and see if it actually does anything important. So let's see, and especially for $60, like, I don't know. We'll see if this does anything. Can't hurt. Famous last words. And yes, the last thing I got, smallest power supply I could find, because we're going to be putting this into a kind of a tight space. The last item I bought is a tiny, tiny power supply. This is not going with the rest of my ham radio gear. This is going on my desk near my window, so I can get the cables in and out and just have it run constantly, separate from my other radio gear for the APRS. And I needed a power supply that was compact. So I've never used Just Verity brand power supplies. Is that a thing? I don't know. Hopefully this will be fine. I've had bad experiences with cheap power supplies destroying the electronics, but the only thing I'll have hooked up to this is that $103 radio. So, I'm not, if something goes terribly wrong, I'm not gonna be too super upset. It's not like I'm hooking my ICOM up to this or anything. And I think I got, the 13.8 volt, 30 amp. So there's two versions I see here. So here's the screen share again. Here it's the universal compact bench power supply, and there are two versions here with 13.8 volts and 30 amps. This one, which has the power pole connectors, which I definitely like, and this one right here, which does not have the power pole connectors, which I do not like. Now we will have to put power pole connectors on to the radio, but that's super duper easy. Here is my current setup. There is a Raspberry Pi. On top of the Raspberry Pi, there is a white box. That white box is a GPS receiver. And if you look really closely in the back, you can see the RTL SDR blog SDR that's picking up APRS. Now this Raspberry Pi is doing double duty. It is an APRS receiver running Direwolf, but it's also this. It is my wall clock. So the idea is that the Raspberry Pi has a GPS hooked up to it using the PPS, or pulse per second input, that makes it have very accurate time. So it's constantly getting the time from the GPS satellites. So it's running ham clock. It just shows me the time very precisely, but it's also an NTP server. So it's a Stratum 1 NTP server, because it's getting data directly from the clocks on the GPS satellites. So yeah, like I said, my wall clock is an APRS receiver, and very accurate Stratum 1 NTP server. Sort of an all-in-one, do everything little device. But the one thing it can't do is it cannot broadcast APRS. We're going to change that. We're going to start broadcasting APRS. Yeah, so step 1 is getting power pole connectors on this. So if you look at the power cable for the radio, you'll see that the ends are just tinned and stripped. So we're going to have to do two things. One, we're going to have to get some cable ties, because these are just loosey-goosey. I mean, you get what you pay for. This is the cheap radio, whatever. And yeah, so we'll put on some power poles. And I was not expecting that we are going to want to put power pole connectors on. Red is obviously positive, black is always negative. Here, so we have crimpers, we have power pole adapters. Whoop, there we go. And we have our cables. We're on some power pole adapters. Let's see. Slide the heat shrink tubing forward a bit. That's at 200 degrees Celsius. I don't entirely trust crimp connections. So, all right, so now we're going to take some of this solder. The crimp is going to be the weak point in this whole connection, so I do like to add a little bit of solder. Ta-da! All right, time to resume APRS. So we have our little cable here, not a problem. Let's see, we have radio. At the other end, we have this little stub. We are now going to plug our newly minted power pole into this. Come on, there we go. But that was a satisfying click. And now, oh, speaking of satisfying, yeah, let's check this out. There's the little screen protector there. That comes right off. The other thing we should do before we plug this in for real is get our antenna plugged in. So this is one of those old-timey UHF connectors. Not a problem. Before we turn it on, we got to plug in the power. So you just got to make sure the power poles are, red goes into red, black goes into black. We are just going to plug this in like so. So put it into the bottom one. There we go. Now we just plug this in. We won't have this plugged in because it's not going to. So this is the little handset. We're not going to have the handset plugged in, but it'll turn on hopefully if I do that. So the power supply is plugged in. Radio has an antenna plugged in. Power supply. Something's going on. Oh, we got beeps. Beeps are very good. There we go. It's making noise. And so here are the settings for the radio that seem to work the best. If we go into the channel description, we see we have it set to 144.39 megahertz, which is both the receive and transmit, since APRS is simplex. We have a channel spacing of 12.5 kilohertz. I set the transmit power to middle, which is about 15 watts, and everything is basically off. That's it. Push OK. And if we go to the function setup, I have the channel locked because there's just one channel. We should not be changing the channel. And we have everything basically default for things like the backlight brightness and everything. You want to make sure that squelch is off. We are not going to be doing any squelch. Direwolf can figure out between when there's noise and when there's a signal. So just keep the squelch off. I changed the knob node to volume because initially or by default it is set to channel, and we only have one channel, so it might as well be volume. I also made sure to turn off Vox because we definitely don't need Vox. The DigiRig has push to talk built in, So we will specifically send a signal to the radio when we want to transmit. And if you don't know what Vox is when it listens for an audio signal to transmit, and we don't need that. So welcome. It's on APRS. So let's start hooking everything together. So let's take the DigiRig cable, the DigiRig to the radio cable. One end has 2 connectors, including this RJ45 or whatever. The other has 4-pole audio connector. So connect the 4-pole audio connector to where it says audio on the DigiRig. With that, you are going to connect the other end to the radio. So this is the audio in to the audio in to the Digi from the radio. This goes into the back of the radio. And this RJ45 goes into the front. Now you take your DigiRig, take your DigiRig, plug in the USB cable, and on the other end of the USB cable, put the RF reducer. And then we'll add the ground loop reducer. We will add the ground loop reducer. And then we plug this monstrosity right into the Raspberry Pi there. So now that the radio is ready to go, we need to set up the audio on the system. And there's a few tricks. So the first trick is if you right-click on the top of the Raspberry Pi desktop, you can right-click on the audio icon here, go down to Device Profiles, and you can turn off the AV jack and turn off HDMI, and only have this USB audio device plugged in, which is the DigiRig. This will make setting up and managing your audio devices much easier because now you only really have one audio device on your system. Next, what you want to do is you want to go into ALSA Mixer and make sure everything is turned up. So we're going to go into ALSA Mixer and we're going to press F5 so we see everything. And we're going to switch to the sound card. So we're going to go F6 and we're going to go to the USB audio device. And everything should be turned up. This is the listening on the speaker. This is listening from the mic. Make sure it's muted. So if you don't see the double M's, push the M key, and then make sure that capture is all the way up. And you're going to escape. And you're going to want to make sure that this is saved for future reboots. So you're going to type sudo ALSA CTL, ALSA control, and store. And now the audio levels are fixed and set, and you're ready to go on to getting Direwolf set up. So I already have Direwolf installed, but I will go over the installation process again. First, what you do is you go to the Direwolf GitHub page, and you're going to scroll down to the installation instructions, which is all the way down here. Keep going. Okay, so you're going to make sure you install all the prerequisites. So these are already installed for me, but I'll just run it again to show you how this works. So we go through and install all the prerequisites. If you don't have any of these installed, it will download it. You skip over the Fedora and CentOS instructions, obviously. And then you are going to clone the Direwolf repository. Now, this repository is pretty large. It may take a while to download. Oh, apparently I am getting new stuff installed. Okay. Despite the fact that I already have Direwolf installed. I guess I was missing a requirement. That did not matter. So let's clone the repository, and it's going to clone into Direwolf. And let's see, so it's 41%. Oh, this won't take too long at all. Once that has fully cloned, I think, there we go. So yes, this will take a little bit to download. And then once it's downloaded, we're going to switch on over to the dev branch and start making it. So we're going to go into the Direwolf directory and switch over to the dev branch with git checkout dev. There we go. And now we're going to make a build directory and change into that. And we're going to cmake the previous directory above, which will give us our make files and everything. And it looks like that's running correctly. And with that, we're going to run make-j4. That is going to make Direwolf. And this is going to take a second. All right, it has finished compiling. And you can install it. I do not install it. I just run it from this directory. And it should be in the source. So it is in the source directory. It's in, if you go into the build source directory, there's the Direwolf executable, and we can do -- version. And as you can see, Direwolf is right here. You can feel free to install it system-wide. I tend not to do that with software I compile myself, but it's just a personal choice. So we need to configure Direwolf, and we need some information before we start configuring the program. In particular, we need the ELSA devices. We're going to run arecord-l, and you want to see what card it is and what device it is. So just make note of these numbers. This is going to be 1, 0, card 1, device 0. We also need to know our longitude and latitude. So you go to the site, find latitude-longitude.com. And what you're looking for is this down here where it says north 41 degree and 40.2 to whatever seconds or minutes, I should say. So yeah, so 70 degrees and 17.5 minutes. And you will need to make a note of that. You'll also need your APRS passcode. And if you just Google for APRS passcode generator, you will find something and you put in your call sign. So you'd say, my call -10. That's what you're going to use for APRS. You get your passcode. This is not it's called a passcode, but it's not really a passcode. It's just like a hash kind of. You get the same one every time. You don't. It's not like a sign up or anything. And now we configure Direwolf. So we're going to go back to our example directory. And in the build directory, there is an example configuration. So we're going to copy direwolf.conf to the primary Direwolf folder here. And we're going to start editing it. So we'll nano direwolf.conf. And the first thing we're going to do is set our audio device. So yes, we go to audio device properties, and here we go. Since we only have that one USB device, the DigiRig set, this is pretty simple. Remember, it was device 1, card 0, or card 1, device 0. Anyway, it's 10, just like we saw from arecord-l. Let's see, and then you have to set your call. So that's going to be my call. There you go. Oops, go down. There you go. So you set my call to whatever your ham radio call sign is. So my for call. And let's see, the modem should be set to 1200. Don't change that. You are going to have to set PTT. So if you're using the DigiRig, you're just going to uncomment this line, which is PTT/dev/TTY USB 0 RTS. If your DigiRig is not this device, change it accordingly, but this should be fine under most circumstances. And then we're going to set off our first P beacon. So here we're going to be in channel 0, I think. Nope, channel 1, P beacons. So just uncomment this. And then you're going to, overlay S is good. Set your longitude and latitude from the website that I talked about. So if it is 41 degrees and 40.27, you would go back and say 41 degrees 27 point, I don't know, 22. Whatever it is, that's how you set your latitude and longitude. Your power is going to be your power in watts. So in this case, since it's in medium, it's going to be 15 watts. At your height, set your gain, probably 2 for a dipole or nothing. You can add a comment here if you want, and you're done. Okay. So we want to enable digipeating. So we're going to search for digipeat. Here we go. So you're just going to uncomment this line like so. Boom. And then you will want to set your iGate server, because this will send packets to the internet. For North America, that's noam.aprs2.net. We're going to set our iLogin. And this is where you use that APRS passcode generator. So in this case, it's 12726. So it would be, my or call -10. And there you go. That's how you would do it. We're going to have another P beacon, this time sending just to the iGate. Set it the exact same you did before, setting your latitude and longitude. And we will also want to uncomment this line. You don't have to change it. Your iGate transmit, so we can relay messages from the internet to the radio. And there are some things you want to add to the end of this. And so here I want to give a huge shout out to themodernham.com. They have some wonderful guides here for setting up APRS and digipeating. Here's the easy APRS gate guide, but we're using the ultimate Direwolf TNC guide here. And the first thing they say is add this to the end, FX 25TX1. So this is sort of like the experimental mode that we will enable. And then it gives a whole bunch of other recommendations here that we're just going to copy and paste, like how long to persist, transmit tail, etc. And copy that. There we go. We're going to exit. We're going to save our changes. There we go. And we can now test our radio by running Direwolf-XA. And what this will do, will just send out a solid tone that you can listen to on your little radio. So if you have like a HT or a walkie-talkie, set it to 144.39 megahertz, the APRS simplex channel, and just listen for a tone. And if you hear that tone, transmit is working. Oh, but you also might want to specify the config file that you're using. So that's going to be -C, as in Charlie. And you're just going to be your home directory, and the safe is going to be example, wherever you put Direwolf, and direwolf.conf. And of course, Direwolf was not installed globally, so would it be in build source Direwolf. So you'd run this command in full to test your setup to make sure it can send a tone. So I have out a APRS radio here. I can transmit control tones, calibration tones from the radio like so, and I will pick it up on my little HT. So I'm gonna run it, and it's coming up fine. So I am transmitting. So I put in, we're going to do a very annoying P beacon about every minute just to test it out. So we're going to send out some APRS packets and see if it gets picked up by other APRS peeps. Okay, so we've successfully. Okay, so at this point, I've successfully sent out a packet using the radio. It got picked up by a receiver. Let's see. So this is where I am. Does it show me who heard it? Can 6. Yeah, there we go. So I am broadcasting from up here and being received all the way down here. All right. Well, I will end the stream then. I am very happy that this worked. It was a lot of configuration. We had to do some wire crimping to get the connectors going, and then just getting all the equipment all set up. Oh my gosh, so much configuration. We had to configure the radios. We had to configure Direwolf, reconfigure the Raspberry Pi, but it is working now. And there's a new Digipeater in the area. So there we go. Thank you for watching me do radio stuff all evening. All right. Talk to you later.